Welcome back to The Explainer. Today, we're diving straight into one of the most fascinating, complex, and honestly terrifying traffic management systems humanity has ever built. It's a system we never actually see, yet, well, our modern lives completely depend on it. So take a breath, slow down, and picture this invisible, high-stakes reality unfolding right now, literally directly over our heads. It's a pretty simple question, right? Can satellites crash into each other? How do they avoid colliding in this vast, seemingly infinite void of space? And, what actually happens when a stray piece of space junk hits a multi-million-dollar satellite? The answers are going to totally change how you look up at the night sky. So, let's get into it. Imagine a highway with 16,000 cars moving at 28,000 kilometers per hour, with no lanes and abandoned vehicles everywhere. Think about that for a second. There are no traffic lights up there, no painted lines, and the wildest part? Some of those cars are totally dead, just abandoned vehicles drifting along this chaotic highway. This isn't some sci-fi movie concept. This is Earth's orbit today. Since the dawn of the space age, we've launched nearly 27,000 satellites into orbit. But 16,100, that is roughly the number of satellites that are still functioning right now. Let that sink in. Over 16,000 massive machines circling the globe, actively running our comms, our weather tracking, our GPS. And they are absolutely not taking it slow. These things are moving at mind-boggling speeds, nearly 28,000 kilometers per hour. At that velocity, they aren't sticking to fixed lanes like we do on the interstate. They're locked into carefully calculated orbits. It's kind of like having thousands of sprinters running on a giant track, but they're all at different heights, going different speeds, and crossing each other's paths constantly. So when people say space is empty, yeah, that's simply not true anymore. Get this. The European Space Agency estimates there are over 1.2 million pieces of space debris larger than just 1 centimeter currently in orbit. 1.2 million. And that's just the stuff big enough to cause serious damage, which doesn't even account for the 50,000 objects out there that are larger than 10 centimeters. Managing space traffic. How NASA and the Space Force prevent disaster. Now, because satellites and space junk don't always behave perfectly, organizations like NASA and the U.S. Space Force have to step in. They basically act as a cosmic air traffic control, running what's called a conjunction assessment process multiple times every single day. First, their computers detect a close approach, basically asking, hey, are satellite A and object B going to be in the exact same spot? Second, they assess the risk, crunching the probability of collision while factoring in all the unknowns. And finally, if it's too risky, they mitigate it. The satellite fires its thrusters to safely dodge the incoming object. But here's the thing. Are functioning satellites the only hazard out there? Well, before we look into the slightly darker reality lurking in orbits, I just want to take a quick second here. If you're enjoying this slower, deeper look into the hidden systems around us, please take a moment to like, share, and comment on this explainer. And definitely hit that subscribe button for more content just like this. Your support really helps us keep unraveling these awesome topics. Okay, back to the true hazards of space. The hidden danger, the threat of orbital space junk. See, while a working satellite can be steered out of harm's way, the real headache comes from the stuff literally nobody is steering. An active satellite has to dodge dead, abandoned satellites that haven't burned up in the atmosphere yet. It has to dodge old, discarded rocket stages. It has to avoid shrapnel from satellites that have straight up exploded. And crazy enough, it even has to survive natural micrometeoroids, these tiny fragments from comets that whip around at a terrifying 10 kilometers per second. To really grasp this, we have to talk about kinetic energy. If you hold a 1 centimeter piece of metal right here on Earth, it's nothing, right? Just a harmless little pebble. But up in orbit, traveling at hypervelocity, that pebble is a bullet from hell. Thanks to all that kinetic energy, a tiny 1 centimeter fleck of paint can punch right through solar panels, fuel tanks, and heavy structural components, hit the wrong spot, and an entire multi-million-dollar satellite is just gone, instantly. When satellites actually collide, real-world orbital disasters. And I need to stress, these collisions aren't just theoretical math problems, they are actual historical events. Back in 1991, we had the Cosmos 1934 impact. Then in 1996, a French satellite named Cerise was struck by a fragment from an old Ariane rocket. That piece of space junk hit so hard it completely ripped off more than 4 meters of the satellite's stabilization boom. But the event that literally changed everything, that went down in 2009. On February 10th, 2009, an active American communications satellite, Iridium 33, and a dead Russian satellite called Cosmos 2251 happened to cross paths about 790 kilometers up. They slammed into each other at 11.6 kilometers per second. This was the first known accidental collision between two intact satellites. In a fraction of a second, this crash showered Earth's orbit with over 1,800 pieces of trackable debris larger than 10 centimeters. It basically turned one local accident into a massive, permanent global hazard. That 2009 disaster points straight to the absolute worst-case nightmare for space agencies everywhere: the Kessler Syndrome. It's a hypothetical chain reaction where the debris field gets so dense that collisions create more fragments, which then cause further collisions, eventually rendering huge chunks of our orbit completely unusable. Think of it like a runaway domino effect in space. Every crash creates thousands of new bullets, basically trapping us on Earth and locking us out of our own orbit. And if the Kessler Syndrome actually happens, the fallout hits your daily life immediately. We're talking losing our navigation and GPS. Weather forecasting? Crippled. The safety networks that guide global aviation and shipping would just vanish. We'd lose vital data for agriculture, disaster monitoring, not to mention satellite TV and internet. The entire invisible infrastructure of the 21st century would just completely collapse. The future of space highways, cleaning up the orbit. Now, thankfully, humanity isn't just sitting around waiting for the sky to fall. Stopping these future disasters requires a multi-layered game plan. Essentially, we have to build a highly advanced air traffic management system for space. The focus right now is on three big pillars: much better orbital tracking and prediction models, smarter satellites packed with automated collision avoidance systems, and, the most crucial one, actively removing the dangerous junk already up there. Right now, companies are building real technology to physically capture and deorbit dead space junk before it has the chance to shatter. Because at the end of the day, preventing one single collision today is infinitely easier than trying to clean up thousands of tiny, lethal fragments tomorrow. Which leaves us with a pretty profound question. Can we actually keep Earth's orbital highways safe as space gets more and more crowded? Managing this invisible highway right above our heads just might be the single greatest engineering challenge of the modern space age. Thank you so much for hanging out with me for this explainer. If you found this dive into orbital chaos as mind-blowing as I do, please hit that like button, share it around, and drop your thoughts in the comments below. And don't forget to subscribe for more deep dives into the wild systems that secretly run our world. Catch you next time.